Let's continue our journey through the structural estimation workflow by talking about how we solve the model that we've come up with. Now, typically, when we think about solving a model, we think about some notion of equilibrium. So in a model where agents are behaving strategically, we might need to solve for the Nash equilibrium or the subgame perfect Nash equilibrium or so forth. If we have a spatial equilibrium model, then we might need to solve for the spatial equilibrium where agents are atomistic, but they take the prices and the quantities that the market provides as given, and so forth. In individual dynamic models, the solution ends up being an optimal policy problem, and we'll show that right now. So we have our lifetime utility function that we discussed in the previous video when we were developing our model. And then we added some more assumptions in the prior video when we were talking about practical specification issues. So we made assumptions about the distribution of the error terms, as well as, given the data that we have available to us, what can we put in for these economic quantities that we want to capture in the model. So these three equations basically define our model, and then we want to figure out, well, how do we actually solve this model? Well, we can adapt our lifetime utility function to match the practical specification that we came up with, and that boils down to a binary choice problem. The person or the people in our sample, they're choosing their schooling to maximize this lifetime utility, where we plug in the equations for UI1 and UI2. And here we denote that UI2 is a function of the amount of schooling that was chosen in UI1. Now, technically, there is a second period work decision that we're allowing the agents to make in this model, but we're going to not think about that right now. We're just going to focus on choosing the optimal level of schooling. And as you can see, the place that the schooling level enters in UI2 is in the amount of earnings that the individual would expect to make. And how do those earnings differ? Well, they're going to differ based on the coefficient on schooling, beta 1, as well as the amount of potential work experience. So if I don't go to school, I don't get the beta 1 wage premium, and I have higher levels of potential work experience. Whereas if I do go to school, then I get the beta 1 wage premium, and then I have lower levels of potential work experience. So how do we solve the model? Well, we basically need to consider the lifetime utility function. And what's going to really complicate things in this model is that the utilities, UI1 and UI2, if we go back a couple slides, these are going to be a function of these unobservable preference error terms. And we made an assumption that these error terms were logistic, but it turns out that when we have these preferences that are not deterministic, we call these random preferences, then that's going to make it more complicated to solve the model. So if we didn't have those, we might be able to come up with some heuristic where people would always choose schooling if certain conditions were met. We're not going to be able to do that in this case because the optimal decisions are going to be probabilistic. So we would just have probabilities of choosing schooling based on the different conditions that we might be interested in, or based on the different conditions that are in the model. So that's a little bit about how we solve the model after having developed the theoretical model and then made specification decisions to help confront what we actually have in the data with what we want to have in our theory. Up next, we're going to talk about how we can tinker with the model to better understand how it works as a check that things are working properly before we proceed with estimation.